All right, my friends, huge thank you to the Innovation Space team for answering our questions and giving us those incredible sneak peeks into different worlds. Now, throughout the event, we've been reminding you of the upcoming digital breakouts, and now we've got one live this main feed. I'll throw it over to Mark Fussell, who's here to talk about distributed application runtime. Mark, over to you. Oh, wait a minute. They gave me the wrong thing. I was telling them this is wrong, and they're like, no, Seth, you've got to do the thing. I've got a panel here with some amazing people. I don't care what's there, because I know half of you. So we've got with us David Carmona, GM of AI Innovation and Marketing. We've got Dan Morris, Principal Scientist at AI for Earth. Hello, look at this. Mark, oh, your last name, Mark?
Hammond.
Mark Hammond, GM of Autonomous Systems, and he's going to talk about Moab. We went there on a family vacay. We're gonna talk to, I remember him. Sarah Bird, Principal PM for Responsible AI. I know her. I talked to her. She's way smarter than I am. And Rangan Majumder, Partner Group Program Manager for Search and AI. Did I get it right?
Yep.
Who needs the teleprompter? I got it all right here on my fancy blue cards. Let's start with you, David. We've had a lot of innovation space talks that look at the horizon. Can you tie this all together for us?
Yes, Seth. So the primary thing that I wanted to have is to really connect the dots to the broader principles that we have for innovation in Microsoft. So that was the intent behind these videos. And those principles start with an innovation that is meaningful. So that's one of the primary goals that we have for these videos. And you can see that throughout the day, I think. So starting with the key themes that we pick, right? So think of course, AI front and center, which was by far one of the core themes of today. But then moving beyond that and thinking more about the future of computing that will be needed for powering that next generation. So we have Rangan, for example. Hi, Rangan, discussing in his session the AI supercomputer and all the AI at scale that was required behind that, to then move into things like, hey, what can happen when you bring AI to the edge to empower the next generation of human-machine interaction, to then end on something even more interesting, which is how we can apply all of this to really have a positive impact in society, like a dance video on AI for Earth. So that's about the first one, meaningful innovation. But then, if there's one thing in common across all these videos, is that if you notice, all of them have stuff that you can apply today. So that's the second thing, applied innovation. So they all had something for developers to use today. And that, I think, was another key theme of today's build. All this innovation is useless if developers don't build like amazing, cool, and interesting stuff on top of it. So a good example here would be Mark's autonomous system video, right, where we provide that platform for developers to build autonomous systems on top of it so they can apply to interesting scenarios. And then lastly, I would say that the last principle is responsible innovation. And a great example of that was Sarah's video on responsible AI, which really goes beyond principles on responsible innovation, but then also how you can apply those principles through practices and tools.
So let's see if I got it right. We focus on innovation that we can apply in a responsible way. Did I get it right?
Yeah, exactly. Meaningful innovation that you can apply in a responsible way.
That's amazing. And how did you come up with the idea for putting all of these videos together and these stories? Tell us how they all relate to each other and what we want to do with AI at this company, at Microsoft. That's for you, David.
Yeah. So you mean in particular AI, or do you want to go beyond that on the videos themselves?
Yeah, because they were interspersed. People may have missed some and gotten the others. I want to see the story that you were trying to tell all together. By the way, for those that are watching, you should definitely download these or watch them later in a row because they're pretty amazing. David, why don't you give them a sneak peek if they haven't seen them yet? No, David. Go ahead. So I'm asking for a secret. Yeah, go ahead.
No, you go ahead.
No, well, I mean, like I said, if you haven't seen them, you should look at them. They're all good stories. One of the things that was in there was a paper from the University of Washington, if I'm right. Tell us about that.
Yeah. Yeah, so this so if you saw some of these videos, they are all happening like in a virtual stage. And the idea came up with, hey, can we in some manner try to replicate the experience that we are all going to miss? Because Build was amazing, but you have that feeling. You really miss being on a physical event, right? So we actually did some research and we look out there and we saw an amazing paper. And I think said we had this conversation in the past on how AI can provide new ways of addressing problems that in the past we tried to address with if then else's, right? And now with AI, we can look at it from a different angle. So that's what this paper from the University of Washington was targeting. And we actually leveraged that paper to create a system based on Azure Kinect that is able to create a virtual experience directly from your home. So super cool stuff that actually you have available in GitHub if you want to replicate in your own events.
See, and I saw that part, and I was like, I need to connect now to make myself be anywhere I want to. It was pretty cool.
Exactly.
Let's move on to you, Dan. AI for Earth. What is that all about? How did you get involved?
Sure. So AI for Earth is about putting Microsoft tools, our cloud, all of our resources to work for environmental sustainability. So we support hundreds of organizations working at the intersection of environmental sustainability and machine learning. So we support those organizations through grants. We build tools ourselves to accelerate environmental science with machine learning. And we also are responsible for making sure that the data that drives environmental science is available on Azure.
So can you give us examples of the kinds of things that you do at AI for Earth?
Definitely. A lot of the work we do, the tools we build here, fall into the category of taking something that environmental scientists are doing right now that is egregiously boring and using AI and machine learning to help them do it more efficiently and help environmental scientists spend more time on science and more time on conservation planning and less time clicking on images. So if you take a look at our technical resources page, we have a number of open source AI projects around accelerating environmental science workflows, a lot of work around wildlife conservation in particular. So a lot of the ways that we study wildlife involve remote sensing data, and that's a ton of raw data that right now somebody typically has to go annotate manually, whether it's images or acoustic recordings. And there's a huge, huge opportunity for machine learning to accelerate that. And again, let environmental scientists spend their time on science instead of on data annotation. And so we look at a whole bunch of different image sources and put tools in the hands of environmental scientists that hopefully make them more efficient and let them answer important, critical questions faster.
So I've seen a couple of things like snow leopard type things. Is this the kind of thing we're talking about?
That's exactly the kind of thing we're talking about. So that particular example uses images from motion-triggered wildlife cameras. We do a lot of work in that space in particular, and that is a paradigm that's replicated all over the world. But there's a whole number of other sensors that have the same kind of problem. You get, if you want to study wildlife, you might put out 500 cameras somewhere and go back to the office and come back 6 months later and pull out 500 SD cards, and now you have 10 million images to sort through, and you are going to spend the next year of your life doing that. And we'd like you to be spending that time planning conservation instead of annotating those images. And so we try to build tools that help you do that faster with AI.
And that's amazing because there's been a lot of time for me to be at home, so I've watched a lot of nature shows, and the snow leopard is quite elusive. And so in a million pictures, you might have 1% of the pictures with any snow leopard in, and so these conservationists are literally wasting their time looking at pictures. How can people get involved with these kinds of things, Dan?
So if you take a look at our AI for Earth technical resources page, all of the work that I'm describing here is open source, and we welcome contributions. So a great place to start, for example, is our open source repo on camera traps. It's github.com/Microsoft/camera traps. Easy to remember. And in addition to the code, we also work really hard to put out, to curate a whole bunch of labeled data to invite the computer vision community in particular to get involved in building models in this space. So if you go to our page, you'll see a link to an open data repository that we maintain with primarily images that are labeled really for the machine learning community to get involved and get excited about contributing to this space.
So let's get a little personal. How did you get involved in this kind of thing? Because it seems kind of amazing. And I have a friend also, Jennifer, who I think works in the AI for Earth team too. How did you get involved in this?
My story is simple. I was in a totally different part of Microsoft for a really long time, and then I probably not coincidentally, the same year I turned 40, I had a mild midlife crisis and decided I only wanted to work on conservation. And conveniently, my midlife crisis was perfectly aligned with the founding of the AI for Earth program by Lucas Joppa, who's now our chief environmental officer and my manager. And so I was working on machine learning stuff before and knew that there was potential for that to apply in conservation also. And so I moved over to the AI for Earth program. Good timing for my midlife crisis.
That's amazing. For my midlife crisis, I want to learn how to fly a plane, but now I feel like a tool because I should have been like Dan. Let's go over to you, Rangan. AI at scale. That's what you talked about a little bit. Can you give us a little bit more information on what you showed?
Sure. AI scale is really about building better products for your customers. So what we noticed is by training really large AI models, you can actually have higher quality experiences. The challenge, though, is these really large models are expensive to train, expensive to ship. So that's why we made like a coordinated effort where we separated the work. So there's a small team training these really large AI models for the rest of the company and also hopefully the rest of the world as we open source these models. And then different product groups like Microsoft Word, like Microsoft SharePoint, they just reuse the models for their scenarios.
So I wrote down a specific model because someone told me about it. Turing NLG model, what is that?
So that's a natural language generation model. It's the largest natural language generation model that's ever been announced. It's 17 billion parameters. It's really huge. And what's amazing about it is you just give it some text, and then its job is to complete the sentence or complete the paragraph. And you could just see like how fluent it is. It can be creative. It has all this knowledge stored inside it. It's pretty amazing. It understands different languages. So it's really powerful, and we think it's going to really close the gap in terms of how machines can communicate with humans.
So I hear about these kinds of things. I'm like, that's cool. We named it a cool name, but what applications does it have in the real world? I'll push you on this a little bit.
Yeah. So the Turing natural language generation model, I have nothing to announce, but we are looking at lots of different scenarios. But you can imagine any time where a person needs to write something, this model can help you finish writing it. So you can imagine that's very useful in writing a Word document or writing an email or even like typing in a search query to Bing. There's like tons of scenarios about that. And even if you've written something, it actually help you refine it. So let's say you've written a story and you're like, I don't like how this sounds. Can you rewrite it for me? All right. So it's going to make people a lot more effective in writing.
So what part of this is open source? Is it open source? Can people play with it, look at it?
Yeah, so the Turing NLG model is not open source. It's pretty large. I don't think many people will be able to use it. But the code to actually train it is open source on GitHub. It's DeepSpeed is the library. And then we have another, like Turing is a family of models. We have this other model we're going to open source in the next couple of months, which is called our natural language representation model. That's a model you can fine tune for a whole bunch of different tasks like query classification, document classification. That one we're using across multiple products today. And when we open source that, hopefully other people can use it. And then to run that model, you need really good software too. So that's why we also have the Onyx runtime for you.
So can you give us a little bit more about the Onyx runtime? Because I used to only think of the Onyx runtime as an inference engine, but now it's also a training thing. Is that true?
Yes, that's right. So Onyx runtime is really great for inferencing, but now a lot of these innovations that we have in DeepSpeed is also integrated into the Onyx runtime. So whatever code you're using, whether it's TensorFlow or PyTorch, you can use Onyx runtime to speed that up.
I've always thought of the Onyx, which stands for Open Neural Network Exchange, as like the PDF of neural network models. Is that an accurate statement, or is my mental model completely off?
Yeah, it's a representation that sort of normalizes how a neural network or any machine learning model is defined. And then by doing that, whether the model's coming from, whatever framework, right, like PyTorch, TensorFlow, we can then take that intermediate representation and then run it really fast using the runtime.
Love it. Sarah, to you, one of the things I struggle with when it comes to machine learning when I'm doing these models is that I have access to pretty sensitive data. And then also, if you're trying to give data to other people to build models or to do anything like a chart, basically this data, it can be sensitive. What do we have to protect people's privacy while still enabling people to gain insight from data?
It's a challenging problem, and in the past, what we've been seeing, right, is that originally people would do things like just anonymize the data. However, what has been shown quite a lot recently is that those mechanisms are flawed and they can be broken. And so in other cases, what's happening is people just aren't using data, particularly for important problems like medical research. And so I'm very excited about the technology that was in my video, which is differential privacy, which is actually a mathematical definition, but the idea being that we can actually, by applying that definition successfully, we can protect people's privacy but still use data.
So let me ask you a question. What if I'm going to be clever, and instead of releasing all of the data, I just release like aggregate, like a sum or an average? That way people's stuff isn't in there. Am I safe with doing that?
No, unfortunately. It certainly is the first step, but it turns out that you might still be able to pull out individual contributions from those aggregate results. So one of the things that we demoed in the video, and we have the notebooks on GitHub so you can go check it out yourself, is actually how you can take aggregate results along with just like a little bit of extra additional information and make pretty reasonable guesses about the private information that went into those aggregates.
So I can basically reverse engineer private data even from aggregate data?
Yeah, and that's happened in the real world too. Our example that we were showing is a synthetic example, but there's been some pretty famous cases where researchers at Harvard and MIT showed that they could take, for example, anonymized aggregate public data that was released, for example, to enable more sort of open data research, and take that and connect it with, for example, the governor's health records and actually show, his private health records, right? And so there's a lot of cases where you can either link it back up or kind of make reasonable guesses at the underlying data.
So you mentioned differential privacy as a mathematical framework. Mathematical frameworks are awesome, when I look at them and read the papers and I'm like, oh, I kind of understand this. But how can people use a mathematical framework to help with this kind of problem?
Yeah, so the work, actually, the idea was published from Microsoft Research and collaborators in 2006. And at the time, it was right away this intriguing idea, but we didn't really know how to do it in practice. And so it was just, theory that was useful in academia. But since 2006, the research community, as well as people actually in practice, have gotten together and really pushed the boundary to create mechanisms and algorithms that apply this definition in practice in different problems. And so now what we've done is taken that collection of algorithms and put them together in an open source platform, which we released yesterday, called White Noise, that makes it easier for people to do this in their applications without them having to go and implement the algorithms themselves or even necessarily deeply understand how they work. But we enable them to understand the privacy accuracy trade-offs so they can still successfully apply differential privacy.
So when I hear the term white noise, I'm kind of a mathy wonk. I'm thinking like, are you applying like a uniform distribution of the data, flipping the bits, so to speak? Is that what's happening?
So the reason we chose the name actually is more just inspired by the idea of like sound masking machines, where people are using white noise for audio privacy, right? They can mask the like individual signal of a person and they can use it. So we liked the name for that reason and the connection to privacy. In the case of differential privacy, the distribution is a little bit different, but the idea is similar.
But having said that, like if I know the distribution that you're using to scramble data, if I sample the data enough, I should be able to reconstruct the original data by subtracting out the distribution used to scramble. How do we protect against that? Because that feels like it's a problem.
Yeah, so there's actually a second mechanism that we need to use here. So differential privacy does work if you know the distribution of the noise, which is great because that means that the people who are actually applying that can take it into account and make sure that the noise is appropriate for their problem. But that means we need a second mechanism, which is understanding how much information we released so that you can't actually release too much information and get around that noise. And so for each query, we calculate how much information was revealed in that query and subtract that from our privacy loss budget.
So basically, you mentioned this budget. Is the budget then like the amount of times you can sample from that disturbed data before you can actually start to understand what the actual data is?
Yeah, and it depends on what mathematical function you're doing, what your query is. Like certain functions might reveal a lot more information, where if it was an aggregate where there's many, many data points going into it, it might only reveal a small amount about each data point. And so the calculation for budget is also part of the contribution here, where there's quite a few different mechanisms that they use to do it to make this actually practical in the real world.
Well, Sarah, this has been very enlightening. Mark, over to you. Why don't you refresh us on what it is that you showed in your video?
Absolutely. So we announced Project Bonsai and Project Moab, which are parts of the autonomous systems platform that we announced as going into public preview. Project Bonsai is a machine teaching service. It provides a pretty fundamental shift in how you think about building intelligent controllers for autonomous systems. Instead of focusing on classical techniques like PID control or working with machine learning and large data sets, you focus instead on what you want to teach and how you teach it. That's essential because in these domains, there's so much expertise. You're not relying on large data sets. You're actually relying on the expertise and experience of the engineers, of the technicians who are working with this equipment. So we want to enable them to teach that to these systems. And so that's what Project Bonsai does. To further enable that, we announced Project Moab. Project Moab is a fun balancing robotics kit that you can use for this kind of machine teaching work. And that allows you to have a playground, if you will, on your desktop that it is easily tied back to the classical control techniques with which you're familiar and the simulation technologies with which you're familiar, but allows you to take that step in a concrete, real physical system with a corresponding simulation built in that can run in the cloud and that can run using professional tooling, and then make that leap over once you've acquired those concepts.
So tell us more about machine teaching, because I'm used to machine learning. How is it different, and is machine teaching appropriate for autonomous systems only, or can we do other things?
So machine teaching is the natural complement to machine learning. It turns out whenever you have a learning system, you have to teach it something. It's just a question of how you're going to go about teaching it. You can choose to use techniques where you have supervised learning and you use lots of data, but there are other techniques that you might use, like reinforcement learning, where you want to provide the ability for a learning agent to interact with an environment, make choices based on that environment and what it's trying to accomplish, and see what happens, and go through that over and over again. Machine teaching allows you to guide that effectively. If you use reinforcement learning naively, it has to explore everything randomly, just kind of figure it out. So you might have to run millions upon millions of trials before you can figure things out. With machine teaching, you're able instead to say, look, here are parts of the state space that are worth exploring. And I know that because I'm familiar with this. I can't tell you exactly how to do it. That's why I'm trying to build an intelligent controller. But I can tell you what is a fruitful area to go explore and the kinds of heuristics and techniques that we would teach to junior apprentices as they're coming in and starting to learn these as well. So machine teaching allows you to shift to that footing of how do I guide the instruction. And it's a complement to machine learning. Machine learning is still there. It's just that you're helping it along. And because of that, machine teaching isn't just for autonomous systems. We leverage it for all the autonomous systems work with Project Bonsai and Project Moab, but it's used for natural language processing. Amazing. It shows up in those pieces of work as well. It's a general technique as opposed to a specific application.
Thank you so much. And sorry to cut you off. They're telling me that we have to throw. Amazing job, everybody. Thank you. Now I'll throw it over to the actual Mark Fussell, who's here to talk about distributed application runtime right now.